Hi, welcome. We're going to do the homework 5, and it's circles and squares, circles in the squares, and squares in the circles. We did a couple problems like these. I don't think we did this problem. Yeah, we did one of these, and one of these, depending on the class. So, okay, let's do it. I want to talk about some basic ideas. Here's these concepts. The concept is, if I know the area of a circle, which we know is radius times pi, another part of that concept is I really only need to know one of these things, and that I'll be able to find the area. So sometimes, let's say if they told me the radius was 3, I know the diameter is 6 because of when I simply look at a picture, 3 over and 3 over would be a full 6 of a width. So that's really the relationship that's happening. And the circumference happens to be the ratio of the diameter times pi. So if we know the diameter, we can merely just take that number times pi. And again, our radius is area is radius times pi. So if the radius is 3, this would be 3 times pi, or 9 pi. These are the concepts of finding the area of a circle. I can either figure out the radius and then just figure out the radius and go straight to here, or sometimes they could tell me something in the middle of here and work my way up and then back down. And so the concept is a picture. It's the relationship between these measurements, and it's actually the information happening here. Okay? The other concept of it is a square. Now, a square has a couple very special features. It's got all right angles. I really don't need to know any of all of the sides, just one side. So if this was a length of 7, then that's a length of 7, that's a length of 7, that's a length of 7. The perimeter is 7 and 7 and 7 and 7. So technically it would be 4 times 7, 28 if those were feet. Make sense? My perimeter here, I notice I didn't even talk about that, but I did in a way because the circumference is the distance around a circle, so it's a special way of talking about the perimeter. Okay? So the perimeter of a circle, the entire circle, is called the circumference. The perimeter of a square, we don't have a special name. And the area of a square is just this side. So if I filled these in like graph paper, there would be 49 boxes in there, and that's what the area of a square. That's actually the concept of that makes a lot of sense, that the area of this square would be 7 times 7. Now, what else could they do to these circles and squares to complicate it? Well, they like to cut squares in half. And when you do that, a really special relationship happens. If that's 7 and that's 7, this distance right here happens to be 7 times the square root of 2. So if I get a calculator, that number should make sense. 7 times 7 times the square root of 2 equals 9.89. So if I had to walk around this triangle instead of the whole square, I'd walk 7 and 7 and 7 times the square root of 2, which is 9. And that distance does look about 9. If that's 7, that's a little longer than 7, and that number is a little longer than 7. Now, you might think, well, what if I forget this pattern? What can I do? You're not completely lost, because if I cut a square in half, that's a right triangle there. So you could use Pythagoras' theorem if you've forgotten this pattern, because one length is 7 and the other length is 7. And this hypotenuse squared we could write it like that. That'd be 98. You could also write this 2 times 49. Isn't that saying the same thing? Isn't 98 2 times 49? But the interesting thing is if I leave it like this, I can take the square root of both sides. So if I take this, and in fact, I can take the square root of everything on the left and everything on the right, and something really magical happens now. The square root of 2 is still there, but the square root of 49 we know is the number 7. So notice where that number comes from. It's pretty neat, right? Okay, so those are some of these concepts that are going to come up over here. And now with these, if we understand these, we should be able to do all of these problems. So let's get started. Grandma's table only fits 4 people, 1, 2, 3, 4. So I bought an insert that would allow us to sit more people. What's the area of the bigger table? So it looks here that the area of this table, just a loose formula or strategy, I think if I know the area of the big table would equal the area of my circle, and it's my circle, and it's the square I added to it, the area of my square. So that's my basic idea, and I think this concept is going to work on all my problems. Let's see, yeah, what's the area of the enlarged table? What's the area of the enlarged table? Okay, so here's my basic concept, and now I'm going to work my way to figuring out any of this information. It says the diameter is 8 feet, so the circle is 8 feet, and that should be telling us something here. That would still be 8, and that would still be 8 when we separate the two sides of the table. And I think if the, wait though, my radius isn't 8. So my diameter is 8, which means my radius must be 4, because 2 times 4 is 8, and that's the relationship between these two numbers. Now that would make my circumference 8 pi, and my area radius times pi, also known as 16 pi. So that's the area of my circle, 16 pi. Okay, now let's figure out my square. Well, it looks like my square, if this really is a square, would have to be, if that's 8, this would have to be 8, and the area of this would be 8 boxes by 8 boxes. Count it all up, these boxes, that's 64. 8 times 8 is 64. So the area of my bigger table would be 16 pi plus 64. And I'd take that as a final answer, I think, on a test, because that's correct. I'd take that. But if this was the EOC and they said rounded to the nearest foot, that's not rounded at all. So I got to figure that out. So 16 times pi, so that's the area of my circle. And then I need to add 64. Okay, and now I'm going to do it again just to double check my answer. 16 times pi and add 64. That's my answer. Okay. So rounded to the nearest foot, and I found area, so my answer should be in feet squared. Okay, let's do it again. Diameter is 10, so if all the way across is 10, and the diameter is 10, the radius, that's the number 2 times 5, so the radius should be 5. Circumference is 10 pi, and area is radius times pi. So that would be 5 times pi, or 25 pi. Okay, so the area of my bigger table would equal the area of my circle, 25 pi, plus the area of my square. So now thinking about this, instead of the number 8, as my diameter, now it's the number 10, so this square should be 10 by 10. So 10 boxes times 10 boxes would be 100 boxes, and that should make sense. I'm now just going to round it to the nearest foot. Okay. You should pause the video and try this one yourself, then play it back and see if you got the answer right. Okay. Welcome back. Hopefully you've got an answer here. Let's check to see if everything went well. If the diameter is 12, then that's 6 times 2. So that would have been, the radius had to have been 6. That makes sense. That's 6, that's 6. So the circumference, which they didn't ask for it, but the circumference is 12 pi and the area is 6 times pi, and that would be 36 pi. So the area of the bigger table, when we've enlarged it, would be 36 pi times my square. So my square here would be 12 is the diameter, so instead of 8, that would be 12. So I'd have 12 times 12, and 12 times 12 would be 144. So hopefully this is matching what you wrote. Cool, right? These are really cool questions. One of my favorites. Okay. Now we're just going to have time on this video to start this, but we did one of these in class. Let's think about what's happening here. The perimeter, and it's only a quarter, so we're going to walk, if that's a square, and it says it's a square, so if it is a square, that would be 8 inches and 8 inches, and this would be something a little longer than 8 inches, maybe about 10 or 11 inches, okay? So this perimeter should be equal to 8 plus 8 plus something a little longer, 10 or 11, and that's my total perimeter, and they want me to round that number to the nearest hundredth. Check out the next video for the rest of the problem.